Hello and welcome to a new In the Mail. It's been a while since we've had one, but don't worry, small packages from China continue to arrive even through the holiday season, and as a result I have plenty of new stuff to show on video. Let's start by taking a look at this module. It's a high voltage Tesla coil. Let me show you the main reason I got it for. Let's plug it in. Okay, so now it's powered on. So yeah, this is basically the main reason I got this thing for, to light CCFL bulbs wirelessly. It's pretty silly, but that's honestly the reason I got it. I wanted to see this experiment live. This Tesla coil creates a high voltage. Let me just unplug it to prevent any electrical shock while I'm handling it. So this Tesla coil creates a high voltage and an intense electrical field around it. This electrical field is induced into the CCFL bulb and excites the chemical inside to hit the phosphorus and emit light, similar to the normal way it would do when powered from the AC line. I'm not sure if there are any other experiments I can perform with this Tesla coil. If you know any, let me know in the comments below. I would love to try some other experiments. I got it from Banggood for less than $10, and it comes with this 9-volt AC adapter, the cheapy ones. From the looks of the circuit, it seems to be using a simple transistor oscillator to produce an AC current for the coil, and it seems to have a feedback winding as implemented as a PCB track around this big coil. In the product page they also show some small neon bulbs, but I didn't get those in my package. Next, let's take a look at some different LEDs I got. First, let's look at this 50 watt panel that works directly off mains 240 volts AC. It has a total of 104 LEDs. These are SMD 2835 LEDs. And the nice thing is that it has the drivers built in. So if we take a look at this aluminum PCB, we see the mains input right here. It goes through a fuse, then through a bridge rectifier, and then we have these 4 drivers. Maybe they have connected 26 LEDs per driver, I'm not sure, haven't checked. You can get this panel with different LED configurations, and also you can get it warm and cold white. So I think these are very nice modules for building your own lighting solution, but you will need to provide adequate heat sinking for dissipating the heat that this panel will generate. Next, I have these 3 LED modules. They are all 100 watts. These two are from the same seller or manufacturer. One is cold white, the other one is warm white, while this third one is from a different seller and it's cold white. This third one is a bit heavier than these two. I think mainly because it has more of this, I don't know, is it aluminum or it's stainless steel? Let's try a magnet. And the magnet is not sticking, so it's probably aluminum. It's interesting to look at these, even though they have pretty much the same specs, 100 watts, 3 amps, 36 volts. When powered with a low current, we can notice the matching of the LED dyes inside. In particular, we can see they do not light up at the same time or at the same supply current, and that is an indication of the quality of the LED module, and usually that's what you get for these low prices from eBay and AliExpress. So here is, for example, this cold white one, and at 23 volts we can see some rows of LEDs started lighting, but not the others. So let's increase this voltage slightly so we can see now the other rows start lighting up, but this means they have different voltage drops, so they are not exactly matched from the factory. Let's also try the warm white one. So yeah, the warm white one at 24 volts, just a few LEDs light up, and as we increase the voltage we can notice slowly the other LEDs start to light up. But there's clearly a brightness difference, and over time this row right here that lights up at a slightly lower voltage might fail. Now this one is at 22 volts, and we can see it kind of lights up at slightly lower voltage than the other two. And at 23.5 volts, almost all of the LEDs light up. So I'm not sure, would you consider this one a slightly higher quality than the other two? I can still see a couple of dies that haven't light up, so not sure. I think this one is also a budget LED, to call it so. So it's basically not what you get when you order from a reputable manufacturer. These are the things you get for a very low price from eBay or AliExpress. If we were to get these from a known manufacturer, you will notice they are better quality and all the LEDs inside light up at approximately the same voltage. Next, I have some of these ultraviolet 3-watt star LEDs. I got 5 of them, and these should be Cree. I'm not sure they are Cree. They should emit at 395 nanometers, and they come with this 20mm star aluminum base. The reason I ordered these was to play with them and maybe have them around for a fun project that involves some UV dye or ink. Maybe next year for Halloween. This year I didn't have any UV LEDs, so I decided to keep some in my lab in case I ever need them. I think I went for the 395 nanometer wavelength because I also found some dye that reacted particularly to that wavelength, but I don't remember precisely. Anyway, you can get these for a few different wavelengths in case you need them. Next, I have this 16 RGB LEDs. This PCB ring contains 16 WS2812 LEDs. These are RGB LEDs in 50/50 package, which have the integrated driver, and you talk to them digitally with an Arduino, for example. YouTube is full of videos showing these LED rings in action. You can get some pretty cool effects by running these lights around. They're pretty cool, so I encourage you to get one of these. They're very inexpensive. For this one I paid $2.40 free shipping. So think about it. That's a PCB with 16 RGB LEDs already assembled for less than $2.50 delivered. So this could be a very nice addition to a variety of projects. Next, I have a couple of modules that might be useful for controlling LEDs. First, let's take a look at this one. It's infrared based, and I think this one only does on-off control by waving your hand in front of the IR sensor, while this second module is touch sensitive, and I think this one also does PWM dimming. So let's put them to a test and see how they work. I have prepared this LED strip which works at 12 volts, and right here on this black and red wire I have 12 volts coming from my bench power supply. So let's first try this infrared one. Let's connect the LEDs to the output. Okay, so we got a blue LED. Let's see. Oh yeah, so it works. By waving your hand in front of the sensor, you can turn on or off the... Can we dim as well? I'm not sure. No, I think this one is just on off. Yes, you have to basically make this waving pattern in front of the sensor, and you can turn on or off your LEDs. I'm not sure of the current capability of this module, but I will check. Let's see if it has anything written on the back. No, but it seems to have a pretty beefy MOSFET in here, and depending on the RDS on of that MOSFET, I think it will be capable of controlling several amps, but I will check the product description and add an annotation over this video. So yeah, this module works really nice. I like it for turning on or off lights. For example, my bench lights. This will be quite a nice addition. But let's take a look at the other module as well, because I think that one also has PWM dimming capability. So let's see. Okay, so we get the same blue LED. Yeah, okay, so this one has dimming. No, I think it's still on off, but it just dims the light until they reach 100% brightness and then back to 0. At least I don't see any way of controlling the brightness to a certain level. So it's still on off control, but it dims the LED to full and then it dims them to low. So yeah, it's still okay, still a nice controller. For example, you could connect this spring to the aluminum heatsink, and the moment you touch the heatsink, the lights will turn on with this nice dimming effect up to 100% brightness. So yeah, not bad. Also a nice module, but I would have loved to have a module that could dim, for example, through 3 levels, 25, 50, no, 4 levels, 25, 50, 75 and 100% brightness, so that I could vary the brightness of the lights on my bench. But these are still good enough, and I think I will use maybe the IR one, because you don't have to touch anything, you just wave your hand in front of them. So I got these from Banggood. They're very cheap and, as you saw, easy to set up. There will be links in the description below for these two products. Next, I have an item that I have waited for approximately 3 months. First of all, it was on back order on Banggood. I ordered one and it was shipped probably 3 or 4 weeks after I placed the order, and it took another 8 weeks or so for delivery. It's the ESP32 module. This thing contains the new chip from Expressive. It's the successor of the ESP8266. It has more power, more IOs, better in almost every way. Unfortunately, it's just the module, no breakout. So I'm gonna wait for a breakout board to arrive before playing with the module. I encourage you to place your order for one because it's kinda new and shipping might take a while. Andreas Spiess is already doing videos on this module, and his channel is a great resource for working with these modules, so check him out. Another interesting module that I got recently is this A7 module from AiThinker. As you probably already know, it's a dual GSM and GPS module. That's why it comes with these two antennas, one for each service. So this might be ideal for building projects that need GPS location as well as GPRS comms. You could build a vehicle tracking system, for example, with this single module. Very interesting module to have, and I wanted to get one since I first saw it, but for now it will go into my box of modules until I'm building a project that needs this kind of connectivity. Andreas Spiess also got this one way before me, and he already has videos about this module on his channels, so I encourage you to check out his channel. This next item was a Christmas present from a good friend of mine. It's the Raspberry Pi Zero. They are a bit hard to find in Romania, practically inexistent, no shop has them in stock, so this friend got me one during his visit in the UK. I think it was ordered from a place called Pimoroni or something like that. Apparently this shop had the board in stock. I have ordered some accessories for this Pi Zero from eBay, including an acrylic case, a mini HDMI cables, and some other bits and pieces. So I'll probably build something using this board in the near future. This next item is a small module that can do touch sensing, at least according to its listing. This caught my attention because I was looking for an easy way to turn on or off bench lights or even other stuff. I quickly realized this isn't gonna do the trick because it doesn't have a high current control switch, but I ordered one anyway just to take a look at. So we get 3 pins and very little circuitry on the small module. There is a TTP223B, which is a single key sensing IC designed specifically for this purpose. This chip can work with up to 5 volts, so let's apply some power and see how it works. So I am supplying 5 volts through the red and black wire to VCC and ground pins, and I am measuring with the multimeter with the through the blue and red wire on the output of the module. So as we can see, it does have an output high enable whenever I touch the sensor, and it does have some filtering for the bounce, at least some filtering, because if I move my finger around the pad, the output stays constantly high. So it looks like the chip is a direct drive output, but there is a pin that allows you to change that to a toggle mode. So instead of only momentarily keeping the output high, if you switch it to a toggle mode, it will toggle the output between high or low whenever you touch the sensor. The sensitivity seems to be nice for this particular module, but you can adjust that by changing the value of an onboard capacitor, but that there is more info on that in the datasheet, so I encourage you to Google that and read the datasheet if you're interested in using this chip. Next item also does some sensing, but in this case it's a module designed to sense current. The core of this module is the INA219 from Texas Instruments. This chip contains everything you need for sensing current and presenting that measurement on a digital interface. Here is a block diagram of this chip. First, it will sense the voltage drop on a current shunt connected at these 2 pins. That voltage is then amplified by this programmable gain amplifier, which is probably a low noise instrumentation amplifier. Next, the signal is converted by this analog to digital converter. Next, with the help of some simple internal logic, the measured signal is stored in a register that is available to read over an I2C interface. This is very useful because you don't have to mess with designing a circuit with a precision instrumentation amplifier, and you don't need to have your own high-resolution ADC. Everything is handled by the chip, and your Arduino can just read the value of the current digitally. In this current configuration with a 0.1 ohm shunt resistor, it can read up to plus or minus 3.2 amps with plus or minus 0.8 milliamps resolution, and up to 26 volts allowed on the differential inputs. Another feature is that it also reports measured voltage and power, so you can read those over I2C interface as well. So a pretty nice solution offered by Texas Instruments in this very small package. I wonder what was the main market or the main products this chip was designed for, because companies like Texas Instruments usually design products like this for a specific customer or for a specific product or range of products, and then they extend the product to the general public. It might have been servers and telecom equipment, because they do monitor power consumption in those very closely. And the last item in today's video is this USB monitor dongle. This one is called Keweisi. That sounds similar to Khaleesi from Game of Thrones, but I'm sure it has nothing to do with that. Nothing fancy here. This is a simple LCD display. In fact, let me just plug it into a power bank. I believe I got this one mainly because it was on sale. A strange thing though, the product description gives a voltage range of 3 to 9 volts, while the product packaging says 4 to 20 volts. And I'm inclining to believe this product packaging because it comes directly from the manufacturer. If it can go up to 20 volts, it's nice because it can potentially measure across quick charge ports as well. Let's put it to a test and see if it will survive 20 volts. So I'm using this connector right here hooked up to my bench power supply. Okay, so right now it's measuring 5 volts. Let's go up to 9 volts. Okay, so it seems to be surviving 9 volts without any issues. Let's go 12 volts. Okay, it does 12 volts as well without any issues. And let's try the maximum 20 volts and see if it really survives that. Yep, we're at 20 volts and it seems to be okay. The magic smoke hasn't escaped so far from this nicely packaged USB adapter. So indeed it can measure up to 20 volts as the packaging says, but the product description on Banggood is wrong. In terms of current, it can measure up to 3 amps. It's got 10 milliamps and 10 millivolts resolution, but that should be enough resolution for a USB monitor. Anyway, it's a product that's on sale again on Banggood, so if you need a USB monitor, nothing fancy, this one might just serve the purpose for a very low price. I hope you enjoyed the video. I enjoyed it myself because these are all items that I like to work with, so I'm really glad I received these items in the mail. Don't forget to subscribe and hit the like button below because that helps with all the recent changes YouTube did, and I will see you next time.